Hello students, this video is regarding the calculations that has to be done to do a gear cutting by using a lathe. Okay, so you must have seen, I hope you must have seen or you must have gone through the manual which I had shared in the Google Classroom. Basically this gear cutting operation, that's exercise 3, you can see I have written here exercise 3. So that's a left hand V thread gear cutting operations. So basically it's a third operation. This is how the model will be. The workpiece which we will give is a 32 mm diameter and 180 mm mild steel rod. Okay, so by using that workpiece we will be doing various operations. The first operations which we will do is a plane turning and facing operation. The second operation which we will be doing is knurling and taper turning. Okay, for knurling and taper turning operations I had already shared the video of doing a calculations of how to do or how to calculate the taper angle and all that. So today the exercise 3, the next exercise is doing a thread cutting operation. So this is how the workpiece which will be. So you can see here the various operations that has been done to the given workpiece. Initially it will be a cylindrical rod of 32 mm diameter and 180 mm length. So using that workpiece, by using a lathe, these are the operations which we will be doing. We will divide the workpiece according to the operations of various length. So in that part we will be doing operations like taper turning. This part is taper turning. This part is knurling. These three parts are V thread and square thread. And the last operation is knurling. Okay. So today I am explaining how to do a thread cutting operations, that is left hand V thread. Okay. So it's a 8 TPI gear cutting operations. So in order to do the gear cutting operations, these are the formulas which you have to use. Okay, so these equations are available in the page number 44. I have written it is exercise 3. So these details, whatever that is there on the board, it is available in your machine shop manual in the page number 44. Okay, so this is the diagram. So you have to do 8 TPI BSW left hand V thread in this place, that is in this portion 30 mm length. In this portion you have to fabricate this thread. Okay, so the formula that has to be used are, one is the pitch is equal to 1 by TPI. Second one, depth of BSW thread, that is equal to 0.64 into pitch. Third one, depth in division is equal to depth of thread by least count. Fourth one, core diameter, that is equal to outer diameter minus 2 into depth of thread. And fifth one is the gear ratio. You can calculate the gear ratio by knowing about TPI on lead screw, TPI on workpiece. So I'll just go through each one of these items, like how to calculate pitch, depth of BSW thread, depth in division, core diameter and gear ratio. So when you know the gear ratio, easily you can fabricate 8 TPI left hand V thread in your workpiece. Okay, so in order to calculate these gear ratio, you should know what is the TPI which they have asked in your exam. As of now, we are calculating for 8 TPI. It would not be the same in your exam. It would be 8 or 7 or any other numbers. Okay, they have clearly mentioned, you can see this is the portion where you will do the thread. So they have mentioned 8 TPI. Okay, so the first equation that has to be calculated is the pitch. Okay, pitch is equal to 1 by TPI, thread per inch. Okay, what is thread per inch? They have mentioned 8. So I have substituted 1 by 8. If you divide 1 by 8, you will get the answer 0.125 inch. Please note this number 8 is in inch. Most of the students, what they do is they will fail to convert inch to mm. So if you fail to convert, you will get the wrong answers. Okay, so this 8 is in inch I've taken the same 8, 1 by 8, I'll get the answer 0.125 inch. Okay. The second one is you have to calculate depth of BSW thread, that is British Standard thread. To calculate that, the equation is 0.64 into pitch. Pitch just now we have calculated, we have got the answer 0.125. So multiply 0.125 into 0.64, 0.64, this is in the equation, into pitch is 0.125. So you will get 0.008. Again, that is in inch. I have mentioned it here. Okay. So when you calculate the depth of BSW thread, the third one is you have to calculate depth in division. Okay. So the equation to calculate depth in division is depth of BSW thread divided by least count. LC stands for least count. Okay. So what is the depth of a thread? Depth of thread is just now I have calculated, that is 0.08 divided by least count is 0.002. The length what we are using, for that the least count is 0.002. Okay. How I got 0.002? The details of the least count is available in page number 44. Okay. So we will get 0.008 divided by 0.002. So you will get depth in divisions is equal to 40 divisions. Okay. So these values what you are getting, this will be useful when you are doing gear cutting operations. When I make a video on gear cutting operations in the lathe, there you will come to know, or there you will come to know how these numbers will be used to set the machines. Okay. The fourth one is core diameter. Core diameter is this part. Okay, you can see this is the place where you do left hand V thread, and this is the core diameter portion. Okay, for example, if you see here, okay, this portion I am calculating, that is what is the core diameter. To calculate that core diameter, the equation is OD. OD stands for outer diameter minus 2 into depth of thread. This is the equation you have to use to calculate core diameter. OD stands for outer diameter. Okay. What is the outer diameter? You can see here. Outer diameter is 1 inch. That means 1 inch you can directly take 1 inch, or you can convert that to mm. That is, it will be 1 inch is equal to 25.4 mm. Okay. Either way you can calculate, but make sure that in what unit you are substituting the values. Okay. So outer diameter I am taking in an inch. 1 inch you can see here 1 minus 2 into depth of thread. What is depth of thread? It is 0.008. Depth of BSW thread you can see 0.008. Okay. OD is outer diameter, that is 1 inch minus 2 into depth of thread, that is depth of thread is 0.008. So if you calculate this, you will get the answer 0.84 inch. Okay. This 0.84 that has to be converted to mm, because the lathe what we are using, ultimately we will set the values by seeing not in inch but in mm. So to convert that inch to mm, I have multiplied by 25.4 mm. You know, 1 inch is equal to 25.4 mm. Okay. So I will get the answer. Core diameter is 21.336 mm. Okay. So this is the core diameter. Now the last step is to calculate gear ratio. Okay. Gear ratio is equal to TPI on lead screw, TPI on workpiece, multiplied by X. Okay. TPI on lead screw, that is unknown. The value of X is also unknown. Okay. What is TPI on workpiece? That is 8. You know that in the sketch that given, it has 8. Okay. So then how to find the value of TPI on lead screw, and how to find the value of X. To get the value of X and to get the value of TPI on lead screw, please refer page number 38 in the page number 38, you can get the answer for this one. What is TPI on lead screw and what's the value of X? Okay, so if you ask me, I can show that. So if you open page number 38, you can find TPI on lead screw. Okay, lathe number 1 is 6, lathe number 2 is 4. Okay, and also value of X, you can see it is 3 by 4. We are not using Sona lathe number 1, we are using Sona lathe number 2 to 12. This is the lathe which we are using. So in that lathe, TPI value is 4, X value is 3 by 4. So same value are taken. TPI on lead screw is 4, TPI on workpiece is 8, value of X is 3 by 4. Okay, so if you calculate that, this 4 and 4 get cancels, so you will get the answer 3 by 8. Okay, using this 3 by 8, it is not possible to fabricate or it is not possible to do left hand V-thread, because the gears that is available is not matching with the answer what we have got. You can see 3 by 8 is the gear ratio what we have got right now, but if you refer page number 44, at the bottom you can see gear that is available. Okay, you can see 30, 40, 45, 50, 55, 60, 80, 90, 100. These are the gears that is available. So you have to convert these 3 by 8 into these numbers. Either you have to get 30 by 80 or 40 by 100, something like that you have to get the value. If you see the numbers, if you just multiply by 10 into 10, multiply 3 by 10 or multiply 8 by 10, what answer you will get is, if you multiply 3 into 10, you will get 30. If you multiply 8 into 10, you will get 80. You should check whether 30 and 80 is available. You can see there is 30. Okay, you also have 80. Clear? So 30 is available, 80 is available. That means gear with 30 teeth is available, gear with 80 teeth is available. So that means your answer is right, and you can fabricate 8 TPI thread by using this gear ratio. Okay, so I repeat once again, TPI on lead screw and the value of X is not known. To get the answer for that, please refer page number 38. There you can get the value of these two unknown terms. Okay, so for this TPI on lead screw is 4, TPI on workpiece, you can see here it is 8 TPI, the value of X is 3 by 4. 4 get cancelled, so I will get 3 by 8. 3 by 8 is not a right value to calculate the gear ratio, because a gear with 3 teeth and a gear with 8 teeth is not available. So that's why what I have done, I have just multiplied by 10 to both the numerator and denominator. So if I multiply, I will get a gear ratio as 30 by 80. 30 by 80, I can say it's the right answer, because you have a gear with 30 teeth, you have a gear with 80 teeth. Okay, here 30 by 80, that means 30 is a driver, 80 is a driven. Okay, so you can clearly understand what is 30, what is 80 when you see the video of thread cutting operations by using a lathe. Okay, so this completes calculations of 8 TPI British standard with left hand V thread. Okay, so if you haven't followed any of these calculations, you can put a comment in the Google Classroom. I can clarify that. Okay, so this completes the calculations. We will show you how to calculate or how to fabricate these 8 TPI by using these values in the lathe. Okay.